Welcome, Michael DeGidio. We're so grateful that you could spend some time with us this afternoon. We don't always get to hear from the computer science angle of things. So please, for our audience, introduce yourself to them. Tell us a little bit about how you got involved in STEM.
Hey, it's nice to see you both. My name is Michael DeGidio, like you said, and I'm a high school computer science teacher. I've been doing that for about the last 10 years. Um, I first got into computer science actually in high school, but it wasn't until college where I really picked it up as a passion and as a love. I majored in computer science at Columbia University. Shortly after that, I had a few jobs kind of in industry related fields, but then I shortly found myself actually in teaching computer science. And that was something that I didn't realize that I would be so passionate about. And I've been doing that for the last 9 years.
That's pretty great. So what are some of the challenges that you see with that? I mean, we think about technology and computer science is like at the forefront, right? But there must be some challenges teaching that to students, especially high school students.
Yeah, it's interesting because I think every discipline has its own unique method, its unique challenges. And I've realized over the course of the last decade, computer sciences have a set of unique challenges that it presents students. I think first and foremost, a lot of students see learning as this rote memorization, knowledge acquisition based skill that you acquire. But I think computer science for many students is that first class, especially with students that I've had that have been traditionally like gifted or academically inclined, where the answer is not immediately in front of them. And it actually teaches students a lot. It teaches a lot about how to develop persistence, grit, determination. It's very rare to write code that works correctly the first time. And I think when students have this first experience of, okay, I spent time on this, it's not working, what do I have to do? And you tell them you have to spend more time on it. It's a challenge for kids. And so I think what I personally loved about computer science when I first started learning it in college was that there was this part of computer science that is very analytical, very straightforward. It does seem like it's kind of like math where there is an answer, right? And it's not like something that's English or social science, which is open-ended. So I think students that gravitate towards those very concrete disciplines like computer science, but I think what's different from taking your standard math class in high school is that computer science it's a combination. It's also creative. It also requires you to be able to be a good problem solver and a good critical thinker. It requires you to be able to chunk really big problems down into small finite steps that you can take towards achieving a goal. And so I find that computer science is like a brain workout. It's really satisfying when you write code and it works. And it teaches you a lot about not just computer science, a discipline I don't think anyone can argue is not valuable, right? It's one of probably the most relevant, valuable skill
Yeah.
set that you can have right now. But at the same time, I think there's a lot that you learn about yourself throughout that process that I find is maybe equally valuable or even more valuable than the content itself.
So many good ideas there I would like to unpack. Let's start with what you said. I think of coding almost like an art, right? A lot of people can write some code that might work, but then you get those students or those folks that are just artists, right? They have elegant code, it's more efficient, it's less clunky. Have you, in your experience, well, first of all, let's start with languages, like the computer languages that you learned. I'm so old. I remember we had a class to learn how to use desktop software.
Wait, I wanted to say, how old are you? That's probably a little joke. You wouldn't even
I
get
will
that.
tell you,
Okay.
when you know what a DOS prompt is, right? When you
Mhm.
work in DOS, a disk operating, it's like pre-Windows.
No, I remember
Um,
DOS. I too am your age.
So in the course, and you're a much younger person, much younger man than we are. So let's talk about in your career path as you were learning computer science. The languages are very much alive, right? Languages come and go. And what is let's just start with languages in your experience with computer science and students. What did you start out when you were a student versus what are you teaching now? And is there much difference or is it pretty much the same?
Yeah, that's a great question. So when I say is being a younger teacher, I'm not young, but being a younger teacher, I simultaneously have to be like try to make myself younger and at the same time try to assert that I'm older. And so I like to think that I live in this like weird gap between like I'm not young yet, I'm not yet old. And so I went to school I went to high school in the early 2000s. And so the teacher that I had for my first high school class taught us in Visual Basic, which is a older language. And Visual Basic is like similar to a language that people would use like if you were programming in Excel. And I remember having like a floppy disk that I had to bring in to save my work. So, I do remember the time when computer screens were black and green, but that was a long time ago. And when I went to college, actually, I had an experience that I think is worth mentioning in high school, that I took this sort of intro to computer science class, and then there was an option to take the AP computer science after that. And I remember the last day of the intro to computer science class, my teacher wrote on the board, like, oh, next year, if you're taking AP computer science, we're going to learn Java. And in Java, they have all of these different primitive types. So when you're programming, right, like you have data, and data is types. So something can be numerical, something can be an object, something can be a string, which is like text. And he went throughout the room and he wrote all of the types that were available in Java. And it just completely overwhelmed me. And I actually dropped the class and I did not enroll in the class. And I think it's so interesting because you never realize as a teacher, just the consequence of every little thing that you do. And it's always good to keep in mind. I think it was one of those, like, computer science teachers often want to kind of scare you out of the class at the start because they want people who are committed and convicted for the study. But when I went to college, then I did take the first class. It was in Java, which is pretty standard, I think, 10, 15 years ago to start in Java, depending on the generation of computer science you're in, right? Like one of my teachers at Columbia, his name was Alfred Aho. He was like the head of Bell Labs at the time when they were like inventing programming languages. And so, I always encounter computer scientists that are from a generation before me, and they're always telling me, you don't know how great you have it. Like I had to go walk to a building and find a stack of punch cards, or I had to go walk to a building and I had to like get printed out output that doesn't just appear on your screen instantaneously. I had to like walk, 10 miles in the snow kind of thing. But for what I do, I actually teach computer science. My first class, I prefer to teach it in Python. Python is not necessarily like a very new programming language. I believe it's from the early 90s, but I think Python is the best programming language to learn when you're first learning how to program, because when you start to learn the differences, like why would I choose one language over another? Java is like a very neurotic programming language. It's typed in a way that, like, if I have a variable and I declare it, I have to say there's going to be a number in this variable. And then Java maintains and asserts that nothing besides a number can go inside that variable. So it's a stricter programming language, and it's also more verbose. To write code in Python and versus write it in Java, you're probably going to end up with a longer program in Java. You also can only start Java. It's object oriented. And so there's different types of programming language. Now, Python is also object oriented, but you have the option to not learn object orientation. And what I'd like to do is try to reduce the barrier to entry. So if I can find that programming language that makes it as easy as possible to begin with, that's why I teach Python. Python, the variables are not typed. They're typed by the value that you put inside of it. So it's just way more flexible. Sometimes I look at Python and I'm like, this looks like English. I think it's a great, accessible first programming language, but it's also not one in which isn't on millions of computers running important code. Like Python's also like an industry standard language, which is why I think it's such a valuable language to learn. But yeah, so that's my thought initially about programming languages.
Right. And my last question about the languages, when you did Scratch and sort of the visual editors come out after you were a student?
Yeah.
And it
that's
seems
all
like
relatively new.
That is how you get the youngest kids going, right? Is a very visual way to teach it.
Well, I was
Right.
thinking, go ahead.
Oh no, yeah. I think I keep thinking from the perspective of a high school computer science teacher, because that's what I've been doing for the majority of my career. But now understanding that there's even a step into programming, which is using Scratch, using some block-based software that removes the grammar, removes the syntax portion of programming, right? Because as an English teacher, how important it is that things are syntactically correct.
Right.
So code follows the same set of even more strict rules, right? So like if I have a sentence in English that the grammar isn't great, you still can sort of imply the meaning behind it.
Right.
But if I have a line of code and there's just one symbol wrong with it, your program will not run, right? Like, and so I think ultimately that's also one of those sources of frustration that kids have. But yeah.
Well, that's what I was thinking as you were describing Java, and like the idea that it's kind of an input and the kid has, at first I was thinking, well, maybe that made it easier for them to actually write the code and have the program work because there was flexibility. But now what I think I'm hearing you say is that because it is very structured, but if you learn the rules of that structure,
Mhm.
then it's easy to probably catch those mistakes. In the same way now,
Yeah.
if I look at a sentence, I can see a comma is out of place because it's before a certain kind of conjunction. So that's interesting. But I also was thinking earlier when you're saying, just in general about the grit of the dropping out, right? So I think about my son who started out in computer science, but dropped very quickly because it was that same thing. And he's 22 or 20, well, 21. My daughter's 22, I guess. So he just couldn't figure out, like, all right, I have to keep spending all these hours trying to get this one little piece together. And it was super frustrating. So it must be
Mm,
hard to get, especially now middle school kids you're working with too, to
right.
have to deal with
Yeah,
that.
yeah. And I think that's the piece where what I love about computer science education is that you if you stick it through, right? Like, and I don't care about what your grade is in my class, right? All I care is that you're trying your hardest, and that you're doing what you can, what's in your control to be as successful as possible. I could care less about the grade that you earn. If you walk out of my class and you say, computer science is not for me, right? But I did learn that if I stick with something, I could be successful, or that or that I have learned to challenge myself in ways that maybe I had not had the opportunity to before. I think it's just as valuable because I often start like the beginning of the school year when parents come in on the first day of school or like back to school night or those kinds of scenarios, and I say like, while I would love it for your child to say I want to study computer science in the future, that's not really my goal. Um, my goal is just to be able to expose students to something maybe that they did find is their passion, or maybe it's not. And I think there is this idea that like kids who are inclined to use computers, kids who are on computers all day, like
Right.
should study computer science. But I think there's a quick realization
Oh,
Yeah. It's
that there
not a
might not be
game.
those. Yeah, those two things may not be correlated
yes.
as much as we think that they are.
Right, right. And I think the biggest benefit of computer science in the secondary school is logical thinking and learning how to deconstruct problems and
Mhm.
learning how to take whatever the task is and organize it. I think it's about
Mm.
teaching critical thinking and logical thinking. Maybe you could elaborate on that.
Oh, for sure. So I think ultimately you will learn. I'm sure you've seen it in your own classrooms. Um, when a student doesn't know what to do, more often than not, they'll probably just like get discouraged, right? Like they're like, I don't know how to do this. And then they'll sit there, right? Like, and then you'll see them and you'll realize they're not working and you'll just gently or politely ask, like, what are you doing over there? And it's like, I don't know what to do. I'm waiting for you. And I'm like, oh, that's not how we're going to be successful in computer science. Like that is not how it works because ultimately, you have to wrestle with this big problem, right? And so to your point, um, how do you make a big problem a slightly smaller problem is like how a computer scientist needs to think, right? Because code is logical and it's also sequential, right? So like no two lines of code cannot like logically entail from each other. Like there, if there is any sort of gap, like computers don't think, regardless of what people say about AI and all that kind of stuff. Um, there, each step to the next step, there needs to be no ambiguity, right? So what I often tell my students is, okay, we have this huge unknown. Let's break it down into a bunch of smaller unknowns. Let's pick one of those smaller unknowns and let's break that down into something that I can do as my next logical step, right? Like that's just the reality of it. You need to get good at knowing how to walk in a direction and sort of like make progress. And that's fine because you're probably going to walk 2 steps back and realize that wasn't the right direction. And then you're going to walk forward another 3 steps. And then you're going to realize, okay, I need to change the way I'm thinking. I need to change my approach. I thought that might work, but I'm actually seeing that it's not.
Would it
And
make sense?
so,
Would
yeah.
it make sense to imagine, because I want to go back to the English analogy, because that's the only thing I get, right? And so
Mm,
as I'm thinking about it, I'm wondering, does it mean then I would have to be able to look at parts because it's too big for me to figure out? But if I found, like, say, a noun in the sentence, I'm going to know that what comes before it would be an adjective because that's how the grammar works. Is it like that? Like I can break it down into sequences to see, okay, I recognize at least this input here or whatever this chain is here. Then if you know the sequence, eventually you're going to know how you put something else in front or in back of it.
Yeah, and I think to that point, when I'm working with students, they'll say like, I need to do this. And then I'll ask them, well, then what do you need to do to be able to do that? Right. Like, and then they'll say, well, I need to do A. I need A. I need A to be true. I need B to be true. I need C to be true. And I'm like, okay, let's look at A. Right. Like, if you really need A to be true, then we know that we have to do these three things. Right. Like, and so I think it's like peeling back, like almost walking backwards from from where you want to be and being able to sort of see that path that you have to take, because there's so many students that just get immediately discouraged. They don't know what to do, and so it's about trial and error, right? Like, and this, everyone can say like computer science is math, computer science, it's usually in a math department. It's not really a science class. Obviously, it's applicable to all fields, but I tell them like the computer science part, when people say computer science, is I need you to just try and see what happens, right? Like, and if it's what you expected, that's great. And if it's not, then we need to change our hypothesis, right? Like, and try again.
Well, that's what I'm starting to think. So it's probably more realistic for a student who's taking that class to recognize you're not going to be able to, you're not going to know everything about this subject when you're done. In fact, if you know one thing, and that's what you're saying earlier, one thing beyond what you had before, that's going to be a step in a much larger direction, because I would imagine there must be a disadvantage for kids nowadays who decide to go in at the university level, but that they're starting where you are with middle school. So it's at least that they'll be exposed to that, to be able to, if they wanted to go into actually start ahead.
It's interesting that you say that, because it made me thought about what you just said, made me thought about how I kind of describe how I'm delivering instruction to students. I tell students, I'm developing your tool belt, right? Like, I'm going to show you how to use a variable. I'm going to show you how to use a conditional, so an if statement, right? Like, so if this variable meets this criteria, then make this decision, or otherwise do this other decision, right? So I can teach you how to use a variable. I can teach you how to use a conditional. I can show you how to write a loop. So I have this line of code. I want to do it 10 times. Okay, let's write a loop that lets you repeat this code. So I'm giving you tools. I'm handing you a hammer. I'm handing you a screwdriver. I'm handing you, whatever. I'm not a handy person, so clearly, but I'm handing you some other tool that you need. And then where the kids struggle is that I go, I need you to build a bookshelf. And they go, you never showed me how to build a bookshelf. You never taught me how to build a bookshelf. And I was like, but I taught you how to use this, and this. So I think, and I think that's that wall that the kids hit, that students hit, where it's like, education isn't just regurgitation. It isn't just rote memorization. It isn't just, well, I've seen every type of problem. I've seen this problem and I just have to change, like in math. I've seen this type of derivative. And so if you give me 3x squared or 2x cubed, I should be able to solve it. Computer science, like it's a open-ended, there's an infinite number of problems, right? Like, and so learning that it's about knowing how to apply what you learn in a meaningful way to progress you towards your goal, and accepting the frustrations that come along the way, because I don't want anyone to get discouraged from computer science education. I wouldn't want anyone to listen to this and be like, wow, that sounds hard, because I think ultimately the value that you get is so much, it's worth that investment. It's worth that sort of that struggle that you might have. And sure, there might be the kind of student who is just gifted and like it isn't a struggle for them, right? But more often than not, I've just seen that computer science is one of those disciplines where people realize you got to put time and effort into this, right? Like, it's not the kind of thing that just you can someone can show you and then you write it down and then you turn the page, right? So yeah,
I would agree with you. And even today, there's a difference in, I'm in your class, my goal is to pass your class, my parents want me to make the honor roll, versus I'm excited, or I want to learn everything about this I can to be as good as I can be. There's a big difference in those two scenarios. Even today, I had a student, he asked a question about dampening equation. And I said, well, just Google it. And then I'm walking around and then I'll come and talk to you. He was looking at a picture of a speaker, and he had looked up, his ability to ask Google even the right question helped me see where his enthusiasm level was for this. And I think your course is invaluable about trying to create active learners, and maybe enthusiastic isn't the right word, but at least an active participant in the learning process, where you're not spoon feeding them answers to questions on a test. It's actually higher order higher order thinking. You're at the synthesis end of Bloom's taxonomy, very much so.
Well, I want to pivot if that's okay, because you mentioned AI, and like we always assume like AI is thinking, like you said, but it's not really, it's programmed to some extent. As a computer science educator and a scientist yourself, what is your take on the way we now have all of this technology that either we can do it for us, or like, is it going to change the way we think? Is it going to replace humanity, like you hear about in the scary sci-fi movies?
I think most people would probably agree that we're very far away from a point when people think of AI as like some like sentient thing that can act and think and feel. When you realize that AI is like really sophisticated math, and that ultimately what's happening is that like there's a lot of information present out in the world that we can learn from, right? Like, and it's funny because a lot of people might, like, if you could see the similarities between how humans learn and how computers learn, like humans learn by like seeing things and seeing it over and over again and learning from those patterns that we see. And AI is the same, right? So like, but what's happening is that it's a kind of like a really fancy statistical mathematical experience that like if I can write a program that goes through text and sees just sort of like what letter comes after the next most frequently, right? Like, and then I can have it learn from a ton of stuff, open a bunch of things, make a model, and then you could feed it a line of text that looks like Shakespeare, and it'll probably complete a page that sounds like Shakespeare. It might be
now too,
Right.
right? So
Yeah.
will that make it easier for the kids to be able to get through if an AI can write the code?
I think ultimately, like where this trend is that people are going to, like any technological advancement, we are going to free humans up to do things that humans are good at, right? Which is like these creative, high level thought process skills or jobs, right? Like I like to say, if you're afraid of some technology replacing your skill set, then we need to like level up your skill set. Now you have AI that can code, which sounds a little bit scary, right? But like there's always going to be a need for programmers. I think realizing that it's best if we can see where these tools add value to our lives or add value to our students' lives, and teach them that there's ethical use of it, just like anything else, right? Like, I'm sure there was a time where people were saying, this calculator contraption, like you need to know by hand how to multiply 123 by 345. And like you using a calculator doesn't prove to me that you actually know how to do that, because you need to do it yourself. And so I think there's some element of that right now where, you could just feed your essay prompt and it's going to give you an essay. It's probably not going to be like, really deep, right? But it'll look like an essay. So understanding that, like, regardless of what we think, these tools are available. They're at our students' fingertips.
There's tools for us too, like you were saying. There's tools.
And
we can use them or not.
Right. And let me throw in a little bit of aerospace, since we are definitely.
Well, yes, that's what I was
let's talk.
How do we use it
in AI, and also I think about autonomous vehicles, right? Like our probes on Mars. They run code that allows them to make decisions, where the instructions from Earth say, go to a certain location on the surface of Mars, but it doesn't tell them the exact path to take. And then the sensors and all the inputs on the ground, they help to find the most advantageous path for whatever rubric, right? Either I got to see some formations, I need to collect some samples, I don't want to get stuck in the soft sand, that kind of thing. Also with satellites, right? Station keeping and making sure your satellite's in the right place. A genuine concern from those of us and people in the military is when you talk about something called the kill chain. When you have a drone, like a Predator drone that flies over somewhere and it has lethal weapons, I know that we never want to let code only decide if somebody's, like if we commit an aggression like that. And I think that's a fair concern, but we're eventually building, devices like jets that can outperform the human body. So our jets will be autonomous probably eventually, right? And so those are, I think, good concerns, and definitely aerospace related. One thing I want to the AI, once at NSF, IBM gave us a tool that was going to sort proposals and classify different research projects. But we had to give exemplars to the tool so that it could learn what the correct answer was. That was interesting. And then we would give it a batch and it would sort them and we would judge its accuracy and then we would correct it. It was very interesting to iterate with like you said, a piece of code. Have you had any experiences in your, because I know you had a life before a teacher. You were in, was it industry, or I know you were not a teacher right out of the gate. So could you share any experiences you might have had with any AI?
Yeah, so it's interesting to the point that was brought up earlier about how quickly technology changes. When I took my AI class, and my AI class is so far from the AI that we have right now.
Yes.
Like the AI class that I had was probably written with, using a textbook that was written in the 80s or the 70s, right? It was more sort of like the first few, first sort of like the first look. And so like AI problems when I was studying them in college were like not at all related to sort of the AI that we see here. And so I have like my only experience of the AI that we have now has come from learning it on my own. And a coworker and I actually taught a class for 2 years at our previous school where we taught students how to use TensorFlow, which is a library for writing code that uses AI. And so it's way different from what I had learned, when I was in college. And also my job in the industry, I was working particularly with web programming. So I was a software engineer for like an e-commerce company. And so one of the things is that there are so many jobs in technology, like in computer science, and many of them are online. I think that's what I love about computer science, right? Like computer science is so broad. You could be someone who is science-based and really like use software and use your code writing skills to do scientific research, right? Or you can use it to do financial programming, or you can go and you could work online, right? And so there's a lot of potential, and there's a lot of different disciplines. And so mine primarily was working and writing code for like a e-commerce shopping platform. And so with that, that's a completely different discipline. I never learned how to do that in college. I had to learn those skills on my own. But then I took that knowledge, which is like using JavaScript, PHP, SQL, which is like a database programming language, HTML and CSS. And I made a class at my last school where students created something kind of like a Twitter, right? Where they had to be able to set up the databases and create the web pages and be able to develop a working program as you see it, because all of this stuff that we use online, it's all code too. And I think some people forget that, or kids forget that. And I think that's also kind of what's relevant to them. They're spending their lives on the computer. They're much more inclined to think of computer science as some sort of skill that they can go and find a really good paying job. And so that's kind of a long answer to your what have I seen in the industry. Yeah.
Well, as I want to be respectful of your time as well, but I have to ask, because we know you in a capacity, obviously, as we're working together, not just as this great font of information for computer science, but also in an area, that is super important. That's the idea of inclusivity. Do you see issues with regards to computer science and maybe lack of representation? Is that an area that we should be cognizant of, making sure that there are role models who look like we do in that field?
Yeah, I think a very simple answer to that is like, well, yes, I do think there are concerns with anything. When I say computer scientist, a face popped up in your mind, right? Like, and just like there's a lot of data. Yeah, there's a lot of data out in the world, and kids and adults learn implicitly from the data around them, right? They learn what a computer scientist looks like. They learn what a doctor looks like. They learn what a nurse looks like, right? And so I think there's a very high need to make sure, particularly this starts from like early childhood, that we are cognizant of the ways in which students learn about what their own capabilities are or about what's expected of them. And that process, it's really kind of hard to pin down, but it's something slow that happens over time, right? So like, depending on what toys I'm exposed to as a child, depending on what areas of interest, what people nurture me towards, right? Like if they tell me from a very young age, like, oh, you're good at math, you're good at this, right? Like I might be more inclined to continue to pursue that as a career. I think it's super important that kids see themselves positively reflected in the world around them, that they see themselves as capable and able, that they understand it. I can talk a lot about this, but the number of women in computer science has gone down since 1970, right? Like it continues to go down. And so I think there is this sense of we need to be thoughtful and mindful of the culture that we create around these things. We need to go out of our way to be inclusive, not just like, oh, I see all my kids as my kids and that's great. Like,
Yeah.
and I love everyone that comes into my room, right? But we need to recognize that if we don't make an active effort to sort of push past the narratives that are circulating around kids when they're young, that we'll continue to see these inequities, right? Like, and it's funny, it's like an activity that I do almost every year where I will go to my school's website, I'll go to Columbia University's website, and I'll press through a bunch of pages. I'll go to the computer science department and I'll press through a bunch of pages. And then I'll just ask my students, like, did you notice anything? Like, what did you notice? Give them a nice open-ended question. And they will almost always be able to articulate something about who was represented on that web page, right? Like, and so I think understanding that it's important to see these examples of success, particularly, and understand just the difficulties that people might face on a path where the presumptions are that they're less capable or less able. We need to celebrate these stories of people who were, excellent despite those things, so that someone else can say, I can do that too. Right? Because if I just relied on the signals that I received as a child about who I was and what I was capable of, I wouldn't be here today unless, without the people who took an active effort to sort of tell me I was capable, tell me I was valuable, tell me that there was a future open to me, one that I couldn't necessarily see around me, right? And I think that's what motivates me to make sure that the door is open to everybody. Right. Like, and again, if the door is open, you still need to get people through the door. So that's maybe that's not even a great analogy.
Yeah, it's a super valid point in that it's one thing for one teacher, one person in a field to say, oh, I personally welcome and encourage everyone. But unless there's a concerted effort to change the availability and the access to everyone, it is it'll always be unlikely that enough of that image, as you kind of suggest, has been imprinted on that young mind. But
well, as a coach, we often say, if you can't picture yourself with that outcome, like whatever the win or the skill, as an athletics coach, but role models help the children visualize maybe they don't have the experience to even visualize themselves as adults, but role models serve that important aspect of providing a visual representation of where they could be. That's why, honestly, college kids are good to talk to middle and high school students, because they're just a few years ahead, right? And by the way, when you said what computer scientists do I think of? Grace Hopper. How about that one?
Nice. There we go.
Yeah, you like that?
Yeah.
Well, oh, go ahead. I was just going to say, because one more question, just for the sake of time. We'll get to that, but please finish what you're going to say, and then come back prepared to share with us as our final question. What advice do you have for that student who might be on the cusp but thinking, man, maybe that's too hard about computer science? But finish your first thought, please.
No, I think it's just like you said, I'm just the idea of a role model and the idea of seeing it is so important. And so I'm thankful when teachers are thoughtful about including sort of all of the people that didn't make the textbook, all of the people whose stories maybe weren't the ones that we continue to tell. And it takes time and energy to sort of put those together. And as time goes on, we're also looking back and realizing, oh, actually, like this person contributed a lot. Like, and that person contributed a lot. And it just wasn't available for us at the time, either because the narrative wasn't important enough, or if it was misattributed, right? Like in science, you have these instances of people, particularly maybe even women, who were involved in some sort of scientific breakthrough, and it's not until after the fact where people say like they're not even named on the research or they weren't even credited. And so I just think it's important that we do that, because oftentimes people say like, oh, all this like identity based stuff, it has no place in a math classroom, it has no place in a science classroom, and like that just like sets an alarm off for me, thinking like, if that's really sort of, if we can, how can we do our good work as educators without having that at the forefront of our minds? So
Yeah, for sure. Well, just any final words that you have for those listening, either who maybe are students who might be like, well, I
mm,
really am excited about computer science, but man, that sounds too hard, or just in general about making it through
Well,
anything.
yeah, let me tweak that. How
Okay.
about a student who's on the fence about
Yeah.
whether or not they should take a computer science class? What would be the strongest, advice you could give them that would say, hey, this is worth a look?
mm. My first reaction to this is just like, what do you have to lose, right? Like, and I think this was important for me because I went throughout the world feeling like achievement was the most important thing. And so when I was praised for doing good work, I continued to pursue those things. And what you'll realize is that kids stop trying things when they don't know if they're going to be successful at them, right? Like, and so part of tearing that down, right, and helping kids sort of become comfortable with trying something where they're not sure if they're going to be successful, I think, is coaching them and helping them realize at the end of the day, like, you have to weigh for yourself, like, what will a grade that is a grade that you're not in love with versus having missed an opportunity to really sort of learn something about yourself, or to find that there was something that actually turned out to be a passion or a future career. um, I have learned to just say, like, what's important for me is that I don't go throughout the world regretting missed opportunities. And so at the end of the day, we also want our kids to be proud of that B that they got, that they worked really hard for, over that A that they wanted. There's been such a focus on sort of performance and grades, being what motivates students to make decisions. And so I want to peel that back and just have students realize that there's different ways to determine it's something being a valuable experience, right? Like, your grade, if we go throughout our academic careers just motivated by what you're sure that you'll be good at, right? Or avoiding things that you fear you might not be successful with, right? Like, I feel like you're pruning your opportunity. And so I would tell you, like, try it. Like, you might learn something amazing about yourself. You might realize that you do love this, or you might realize that you can tell yourself, well, no matter what, I like figured out that I can make it through, right? Like, it was difficult, and but I'm proud of the growth that I showed, even if it wasn't ultimately what I ended up wanting to do for my future. There's really nothing to lose.
I
So
think that's a perfect ending spot there. Obviously, we'd love to have you come back and talk more, and we'll do that in the future. But thank you so much for sharing your information with us today. We greatly appreciate you being here.
Thank
thank you
you.
for having me. Thank you.